Now? Better? Okay, thank you. Hello, everyone. Good morning. Well, my name is Eduardo Silva. We're going to make a deep dive about this project, which is called Fluentd Bit. And I would like to ask, who is using Fluentd Bit? 3, 4, 5, 6, 7. Yeah, that's good. Okay. Okay, I'm a principal engineer at ARM and Treasure Data. Treasure Data is the creator of Fluentd project and Fluentd Bit, but now we are part of ARM. And in my daily role, I maintain this project, which is called Fluentd Bit, which is part also of the Fluentd ecosystem. Okay, and before to start talking about this, we need to explain a little bit about logging. Logging, in general, is not fun, it's not fancy, but you have it because you want to accomplish this, which is called data analysis. And when you want to accomplish logging, you usually has many kind of source of information. Okay, and this source of information, I mean, can be log files, messages arriving from TCP, UDP, or any kind of different channel. And also the data that comes and flows through these channels comes in different formats. So as you can realize, logging by itself is quite complex because it's not like every environment has like a JSON format logging standardized or one binary format. In reality, you have different formats, different ways to collect data, and we need to have a way to deal with that. Okay, so how to deal with this? Years ago, when Fluentd was designed, they came up with this design, which is called the logging pipeline, meaning that if you're going to deal with logging, you need to go to different phases to accomplish this of process data from multiple sources, multiple formats, and send that data out. So basically, we said that we have an input, means from where we collect the data, right? TCP, UDP, or the file system. Then we have a parser, and the parser section or step means how I'm going to interpret this data. Right? It's not the same to interpret like Apache log format that a JSON map. They're totally different. But we need to have a way here, hidden inside the logging pipeline, to centralize and unify this in one generic format for logging purposes. Then we have the filter, which basically said the filter is like, okay, sometimes you would like to have all your data that is flowing through the inputs, but maybe you would like to drop some data and say all this data that's coming from this specific TCP port, maybe I don't want all of them, maybe I want a fraction, or maybe I just want to discard it. Or maybe I want to append more information to this same log. For example, in Kubernetes, the filter is really important. If you're running Kubernetes, you have the container is appending the message, right? You have the message, you have the container name, container name, container ID, pod name, but also you would like to get labels and annotations, and that information comes from the API server, and you need to have a filter to accomplish that. We're going to explain that a little bit. And then you would like to have some kind of buffering, because if you collected some data here, what you don't want in logging is lost data. You don't want to lose data. So buffering allows you to take this information that you got from somewhere, you parse it, you filter it, and stay safe in one place. Can be either maybe in memory or the file system, because you're going to flush this data to a cloud service or a database. But as you know, the things can go wrong. Okay, in networking, things fails. Well, like in everything we related with computers. So if something happens here and I cannot flush the data because maybe my output is Elasticsearch and it's down, I need to have a copy of that data for persistency and then retry that later. So don't lose your data. And then we have this kind of, which is called the output destinations. It's a way, how do I connect? How do I transfer my data that got from input, was parsed here, and how to convert that back to the format that is expected by the output destination. For example, Kafka has its own format for data, right? It's a binary format. But Elasticsearch uses a JSON format. So the logging pipeline allows you to say, okay, if I'm going to connect from one place to another, I need to convert the data in the proper way. So this is the project that we are speaking about today, which is called Fluent Bit. And Fluent Bit is a project which is part of Fluentd. Do we have Fluentd users? Fluentd. So most of you get familiar with Fluentd. Okay, so Fluent Bit itself started on 2015. Fluentd started on 2011, if I'm not wrong. We have the Fluentd maintainer here, Masahiro. And originally, Fluent Bit was created for embedded Linux. But happened that in the embedded market, people was not, so in embedded in general, people do not have really standards for everything. It's not like in the cloud. In embedded, every company or every stack tries to solve the problem on their own way. Okay, so what I'm trying to say that Fluent Bit got a little bit of traction in embedded, but where it got more traction was in the cloud space. In the cloud, I'm saying with Kubernetes or different kind of cloud services, because Fluent Bit was designed to be more small, lightweight, and more performant for specific scenarios. Okay, but of course, Fluent Bit is not in the same scope of Fluentd. Fluentd has like 800 plugins. Fluent Bit has 45. And nowadays, Fluent Bit is widely adopted and it's being used a lot in Kubernetes. Just in the last 10 months, we got like 13 million deployments of Fluent Bit only. Yesterday, it was like 100,000 or something. And that is crazy. That means that every Kubernetes node that is being deployed, it's either running Fluentd or Fluent Bit. So the main difference is that Fluent Bit is a project which is written in C language. It's made for low memory and CPU footprint. It uses around 500 kilobytes in memory. But, of course, if you're ingesting data and processing data, that memory will go up, right? So this is true, but it depends on the use case. We have a pluggable architecture where you can extend Fluent Bit, mean how to extend in plugins in input side, how to collect data from new places, or how to add new destinations. And we have also built-in security through Embed TLS. We provide secure sockets and for network IIO. So how Fluent Bit works internally? Because we said we have a design of a logging pipeline, and also we need to take data from one place to another. So in general, Fluent Bit runs in one single thread. It's like a main process. We don't do multi-threading stuff. So we have one event loop that is always trying to collect new events that are happening. So the input plugins, for example, if you consider a log file, the input plugin that reads logs will read the log until some point, and then Fluent Bit will tell the kernel, please let me know when this file is changing. If this file is changing, send me a notification, and the event loop will get a notification. So basically, the event loop get data from the input plugins pass the data to the filters, and filters notify back the event loop when the data has been processed back. And then the information is sent back to the output destinations. And output destinations can be any plugin that is already implemented on Fluent Bit. Here we're talking more technical things because we assume that we have some knowledge about Fluentd or Fluent Bit or logging in general. Okay, so Fluent Bit in data processing, it can deal with unstructured and structured data. The famous example of structured data, like Apache log file, is an unstructured message. You don't have a structure. Maybe you can read it, you can understand it. There's an IP address, there's a timestamp, but after that, for a computer, it's just bytes, right? It's different, a structured message, for example, JSON, where you have a map, you have a key, and you have a value. Because if you want to do data analysis, you want to do search over specific keys that exist on that record, and not the whole string. And if you want to do data processing and convert unstructured data to structured data, we support different mechanisms. One is with regular expressions, we support JSON and LTSV. And there's a new one coming up also. And we also support time lookup resolution. So When an input plugin, for some reason, wants to ingest a log message into Fluent Bit, what it does, it creates the notion of a record. This is like a log line, just an example. And this log line has two things. The first one is a timestamp, meaning when this was generated, and also and the message itself. It tends to be a map. But the difference is that internally, inside Fluent Bit and in Fluentd itself, this data is serialized in binary in a format which is called message pack. Do you know JSON? Okay, JSON is like human readable data, data structure, right? But this is totally binary. What means that binary is if you have a lot of bytes and you have a lot of key values, you don't need to go to each byte, processing each one to know where this value ends on the next one is starting. You just jump in between positions. Okay? That is not possible with JSON. But with message pack, which is binary, is possible, and that helps you to give you a really good performance. So input plugins can generate many records. And these records are ingested, and also they are grouped in a concept which we call the tag. So for example, if we are reading log files from an Apache web server, we likely want to add a tag which is called apache.vhost1, virtual host, whatever. But also the plugin, another plugin can be ingesting records that come from syslog. And we create a tag for them which is called syslog. And tags are really important because at the end what we're doing is try to put some context about where this data comes from and where this data is going to. So things get more fun here because everything that was grouped here with Apache and here with syslog gets into the engine, but basically in the router. And the router will say, okay, everything that match with Apache.something will go to output plugin 1. Everything that matches with syslog will go to output plugin 2. Or maybe you can send the same thing to both or many destinations. So it means if you are collecting data from one place, you can send that data to multiple places without any problem. So output plugins, most of them relies on network I/O, means that they need to connect to a service to send the data through. For example, Elasticsearch, if you connect to Kafka or you use any kind of cloud service provider for logging, you need to perform a network operations. But from a design perspective, are you developers? We have developers in the audience? Okay, if at some point you try to connect to a service, you know that you need to create a socket. That socket connect to an address, resolve that address, and then wait until that connection is established, and then you can write or send the data to that service. But if you have plugins and you are in that people will start creating multiple plugins, there are many scenarios where things can go wrong. Like I try to connect to this host or this service, but the DNS failed. Or maybe you were writing the logs and maybe something happened, a network outage, and this goes wrong. So if you provide a way to extend a logging component, you also need to be aware that things can go wrong. And when working with events and in technical terms, with one thread, you want to avoid what is called the callbacks hell when you're working in an event-driven mode. So also we come up with a design how to implement output plugins that do not block the whole process. So basically an output plugin, what it does, create a TCP connection, convert the internal message pack that we used to have to the outgoing format. Remember, for example, if Elasticsearch is using JSON format, I need to convert my own message pack that I just explained to the JSON format. Then write the data over the network. Then wait for a response, right? Because Elastic uses HTTP. And then report a final status if it was okay, it failed, or whatever. So these three things that are in red right now are things that can block my program. Because if I'm waiting to get a response, why I'm blocking Fluent Bit? Why I'm blocking, I'm stopping processing more logs. Ideal case will be, okay, I'm trying to make a connection, let the kernel or the operating system, please let me know when this is ready. In the meanwhile, I'm going to do my other stuff, like collecting log, parsing, filtering, and notify me back through my event loop when this is done. So the design of Fluent Bit was also to try to avoid blocking times on here. So when Fluent Bit is going to flush the data that is buffered, right? We have buffers. What it does, it creates a coroutine for the plugin. And a coroutine can be called like a lightweight thread. Okay, it's not operating system thread. It's at the user space level. All network operations, that means connect, write, or network I/O in general, are abstracted by the Fluent Bit API to handle all of these things at TCP and TLS level. Means if you want to connect, for example, you're writing a plugin and you want to connect to a service who use TLS or SSL, of course you don't want to do your own manual handshake. What you do is just use the Fluent Bit API that provides you the whole abstraction for that. And in the asynchronous side, network I/O, you can suspend a coroutine, means if I'm connecting to a service, I can suspend on that moment and resume later. Return control to the event loop, and when an event happens, resume and continue working. So I'm not sure if you're familiar with C language, but this is just like a very simple output plugin for Fluent Bit. What it does is connect to Elasticsearch, convert the data, and send the data to the service. Okay, this is a function definition. Okay, the name is random. What we have here on line 8 is just get a TCP connection to the service that was defined in the configuration. We call it an upstream connection. Okay, that's fine. Then we convert the format because we have data, which is message back, to the outgoing expected format. This function is not here for. It's outside in a different file. Then we create an HTTP client context, and then we flush the data. And once we flush the data, we return an status. So the thing is that on this point, when we create the connection and we are writing the data over the network, we have the whole suspend and resume stuff. So if you're writing a plugin for Fluent Bit, you write it like this. And you always will care about just one return error. Okay? But if you don't have this schema, you have to do all the networking stuff on your own plugin, and that is quite complex, and it's not that easy. So this is one of the biggest features, and I think that helps also to provide some stability to the project in terms of if somebody is writing a plugin, I'm sure that if they are using the right API for Fluent Bit, that will be safe. So when the output plugin ends, it must return a value. It can be OK, a retry, or an error. An OK means that, okay, I was able to flush the data. Perfect. The plugins just return a status. They don't handle retries. But if they return back a retry, for the engine means, oh, this plugin tried to deliver the logs, but for some reason it failed, but it's asking to retry. Means wait a couple of seconds and retry, call me again later to see if the problem is solved. So if this plugin has not tried many times, because you can put some limits on it, it will issue a new retry. Or maybe you can have an error that you cannot handle because the message pack data can be corrupted, or any exception that the plugin considered that the data will not be processed again. That's how the transfer data from one point to the other works. So when I say that we have an API, also I say that we have built-in helpers. Because if you are a developer, you are extending Fluent Bit, you need to have these things to upstream connections, something that handle the connection for you. You need to have an HTTP client. For example, the Microsoft Azure service, if I'm not wrong, no, sorry, Google Stack Driver use OAuth 2 as an authentication mechanism, so we provide a helper for that. Timers, crypto libraries, and Lua. I'm going to explain about Lua in a few seconds. So this is a list of a few plugins that we have implemented. For the context of the conference, what is really important in the input side is tail to read log files, systemd. If you're running Kubernetes, or the logs go to the file system or they go to a systemd. So we support both mechanisms to consume logs from. In the filtering side, which is important for Kubernetes case, it's like filter Kubernetes. I'm going to explain that because if you're running containers and you process those logs, you want to append metadata to those logs. And we support a filter which is called Lua, because some people said, hey, I would like to write a new filter for Fluentd Bit. Perfect. What your filter will do is like, no, I need to add some conditions for the data, that if it's an if, an else, and then blah, 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 blah. So a very specific use cases, and you cannot merge a plugin for something that is very specific to one user. So we created a filter which is called Lua, so you can write your own filters in a Lua script in a configuration file, and then the filter will call that. We are going to explain that. And as an output destination, well, we support Treasure Data and the service that we provide, HTTP endpoints, Elasticsearch, Splunk, Azure, Kafka, so on. So this is like a simple filter reading in Lua language. It's just a function that it gets the tag, the timestamp when this was created, and the data. This does not come in message pack, it gets in Lua representation data, which is called Lua tables. So everything in the record is like a table, like an array with an index. Basically, just create a new record. I say new record, the new key, but we'll have this value, the old value will have the old record. Return 1, the first status code means if I'm going to delete the record, modify it, or just do nothing. Once means I'm going to modify it. I keep the same time for the record, and then just return the new record. So if you want to do this in C, you will write like 200 lines, right? So you can write filters very easily in Lua. And the good thing about Lua language is that we have a just-in-time compiler for it. So as of today, it works fine. Nobody complains. So a little bit about log processing in Kubernetes. I'm assuming you get some notion about what Kubernetes is and how it works. So you have Kubernetes, you have a master or API server, and you have nodes. Okay? When you have containers and applications running, you need to process the logs from the pods are being generated in the file system. So what you do is to just deploy Fluentd Bit or Fluentd as a daemon set. Daemon set is just a pod that runs on every node. And you just let Fluentd Bit read the logs from the file system. Okay, this is like a tail input, right? And consuming the data. But then you want to append some metadata and enrich those logs. That's when the filter Kubernetes of Fluentd Bit or Fluentd, the same case, goes to the API server and get the labels, get the annotations, and merge all that information back in the same record that was originally read here. So a simple example, this is like a message that was generated by an application. Docker create all this JSON map with a key called log, with a string called standard output and the timestamp. But after that data is filtered, you get this, because you get the whole notion about what is the pod name that this record was created, what is the container name, the namespace, the host, and so on. So logging in Kubernetes is also complex because you need to correlate information that comes from the node, but also information that resides in the master or API server. One of the features of Fluentd Bit specifically for Kubernetes is that people said when you're running applications, maybe you're deploying Apache, maybe you're deploying Nginx, or any application has a different format for logging. Okay? But in Kubernetes, we needed to have a way to say, if you are deploying a pod, an application, say, please use a parser Apache because my application is running Apache. So we implemented this kind of annotation for Fluent Bit where you can define your own parser. Of course, this parser exists on Fluent Bit configuration before. And also, this feature just got expanded a little bit more a few weeks ago, where your annotation, you can say, because in one pod, you can have many containers, and many containers can come data from different streams. So now you can make an annotation saying, please, parser. For this container name, on this stream name, use this parser. Or for the parser that on this container, this parser. So you can use any option that you want. And also, we have an option which is called Exclude, because you're deploying a pod that you don't care about the logs of that pod, and you want to exclude it. So Fluent Bit, when correlated data goes to the API server and get the annotations, will say, oh, this pod is being asked to be excluded. So I'm going to stop processing the logs from that pod. Also, in Fluent Bit, we provide a way to measure how things are working internally. Are you familiar with Prometheus? Okay, Prometheus is a solution to gather metrics from services and aggregate metrics. You have login and you have metrics. Login, Fluentd, Fluent Bit, metrics, Prometheus. So with this way, we allow that you can put your own Prometheus and pull metrics from Fluent Bit to try to realize how many records are being processed per second or gather your own metrics. And now we are preparing for Fluent Bit 1.0 to be released on December on KubeCon. And one of the specific features that people were asking a lot about it is file system buffering. When you are processing the data, I mentioned at the beginning that you have buffering, right? By default, the buffering is just in memory. For example, Fluentd was from the beginning has buffering in the file system and in memory. And why you want to have two different buffering mechanisms? Because sometimes if you're flushing the data out to for example, Elasticsearch, and Elasticsearch is not working fast enough, you get what is called back pressure. Because you cannot send your data, so your data gets buffered, but also you're consuming more data. So you're blocked. And at some point, you need to put that data somewhere. If you put that on memory, and Elasticsearch is always down, your process will crash, or you will gonna get killed. But instead, what everybody does in production is to use the file system, because people say, oh, it doesn't matter. I have like 10 gigabytes in the file system. I'm going to use that as a buffer. So if something happens, I continue buffering in the file system. Write optional plugins as shared libraries. As of now, Fluent Bit is written in C language, and all plugins are linked statically. So the new change is that they will become like shared libraries. The Kubernetes filter continue getting more improvements because we always get more ideas. Yesterday we were asked to take the Kubernetes filter. They said we work for Google. Okay, we are use Fluentd, that's perfect, but we want to start experimenting with Fluent Bit. But the thing is that when we provide the Kubernetes cluster to our users don't have a way to exclude logs or just log special pods that belongs or have special labels. So we are going to provide special ways to say any log that's coming from a specific Kubernetes label, just drop it or just let it pass. And well, this is already done. Static configuration mode. This is mostly for embedded stuff, where sometimes the services or the system where it's running Fluent Bit doesn't have a file system, so you cannot provide the configuration file. So you just merge the configuration inside the same binary or executable. Well, that was the presentation, and I would like to know more about if you have questions about Fluent Bit itself. I know that sometimes it's confusing. Should I use Fluentd? Should I use Fluent Bit? Or so on. Questions? Sure.
I have one question. So I'm not sure if this is relevant with Fluentd directly or relevant with the Kubernetes feature.
But right now we are using Docker Swarm. Within Docker Swarm, it has the capability that you can specify a logging driver so that you can actually collect part of the containers in your cluster and send this specific logs into your destination. However, for Kubernetes, as you mentioned previously, you can only monitor the file system, which means you need to collect all the logs in the entire Kubernetes cluster. However, this is not possible for us because sometimes our customer deploy the application into a shared Kubernetes cluster. So we don't want them to collect non-relevant application logs within this cluster. So is there any solution to this problem?
So there's a design problem. Looks like a design problem. Because, okay, you have a shared environment, and you don't want to provide one login tool for the whole users, right? Correct. You want to isolate.
Correct.
So the way to isolate is with namespaces. The way to isolate is with labels. So you can configure the log processor, can be Fluentd or Fluent Bit, and just say process the logs that belong to a specific namespace. You run it as a daemon set, but it will process the logs from that node, but specifically to one specific namespace. Because I'm sure that some customer wants the log in one database and the others in another one.
So do you mean that, because you mentioned that Fluent Bit can be configured to monitor the file system, but in that case, I don't think it can be retrieved the metadata from Kubernetes because a file system only contains some, let's say, for example, abcd.log file within the file system.
No, actually it happened that in Kubernetes, the way to work is that the log file contains the pod name and the namespace. And with those two values, you can go to the API server and get the metadata. But that is the filter job. So don't worry. If you look at any cluster and you go to the container logs, you will see that each container log contains the pod name, the container ID, and the namespace name. And that information is processed by Fluentd or Fluent Bit and goes to the API server to gather the right metadata.
So the filter, is it the filter within Fluent Bit, or is it a filter for Kubernetes?
It's called Kubernetes filter. That's inside Fluent Bit and inside Fluentd.
All right. So it's a new feature for Kubernetes. Is that correct?
No, it's not a Kubernetes feature. It's a Fluentd and Fluent Bit feature.
All right. Okay. Thank you.
So we have a filter to work in a Kubernetes environment. Okay. That's what I wanted to say.
Thank you.
Welcome. Yeah.
I had a question about the output plugin system. So I think you mentioned there's 3 states the plugin has to return. One of them was error. So that basically, if I understood it correctly, means like for that output, we're giving up this log and you don't need to try again. Is that correct?
Yeah, an error means that the data will not be retried.
Okay.
And recover error.
Okay, because I was thinking like in a case, suppose I have like multiple outputs, only one of them maybe the consumer is having a problem, right? So I believe if all the plugins keep returning retry, then I believe the default behavior for Fluentd would be to just buffer everything until all of the outputs are okay.
Yeah.
Is that
Yeah, it depends because Fluentd in the buffering mechanism Fluentd is different than Fluent Bit.
Okay.
In Fluentd, the buffer exists at the output side of the queues. They're output queues. So the data can be replicated if an output plugin already created some special data to flush, formatted the data. Mm-hmm. That data is in the buffer.
Okay.
In Fluent Bit, we always reformat the data every time that we're going to retry. So if you have the data here and it goes to multiple places, in Fluent Bit, we just keep one copy of that data here.
Okay,
single buffer. And we have counters about which one needs to be retried.
Okay.
When all succeeded or all succeeded plus error, then we just drop the data.
Okay, so if at least one of the output consumers is having a problem in Fluent Bit, you have to keep the buffer growing. Is that correct?
Yeah, unless you say that there's no retries, because you can configure the retries. You can say no limits, or you can try twice,
Okay, right.
Or maybe no retries.
Because I was thinking like then the plugin could be smart enough to know when to stop retrying and then just return an error. I was wondering where that logic should go.
Yeah, actually in Fluent Bit, the plugins doesn't have a notion about if they are going to be retried or not. That is handled by the scheduler in the engine.
Okay.
So the plugin just know how to get the data, format the data, and flush the data and return a value.
Okay, got it.
That is up to the engine. Otherwise, you give too much power to the plugins.
Okay,
and I think that it's better to have control over that.
Okay.
Yeah.
Just final quick question. Like, do the plugins have to be written in C, or is it possible to use other languages?
Actually, we created an extension last year about to write output plugins in Go, but it works. But it just works. The problem is that when you have C code and then you connect to the Golang world, okay, your C code goes out of the scope. Because it's a switch, it's a context switch. You know, Golang takes care about that. So the login processor stopped working. And then it just recovered when the Golang returned the control back to Fluent Bit. So that's why people sometimes prefer to extend the HTTP output plugin to customize the output for their own needs. You have to finish and not write something in Go that can block and affect performance.
Okay, thank you.
Thank you. We don't have more time for questions, but we can go outside. No problems. We have time. Okay. Thank you so much.